Dear friends, welcome. Today we are going to study mathematical physics. As a continuation of the last class, we are going to study complex integration. Today we are going to look upon how we can do problems of complex integration along semi-infinite circle. Semi-infinite circle. So, if we are taking integral of minus infinity to plus infinity, f of z dz. So, this is our region. Minus infinity to plus infinity, here x. So like this we are taking. So type 1 is if the contour contains imaginary, means poles doesn't lie on x-axis. So for this case, equation is integral c f of z dz is equal to 2 pi I summation over residue minus pi I limit z tends to infinity z f of z. Here z is equal to a plus or minus ib and or z is equal to plus or minus ib since pole doesn't lie on x-axis. So we can say that integral over c f of z dz is equal to 2 pi I summation over r, because the part where pi I limit z tends to infinity z f of z is equal to 0, is equal to 0 according to Gauss Jordan lemma. So the equation has turned out like this: integral over c f of z dz is equal to 2 pi I summation over r if poles doesn't lie on x-axis and it contains, that means it is an imaginary. And type 2 is poles doesn't lie on y-axis. Z is equal to plus or minus a, means only a real number. So integral over c f of z dz is equal to pi I summation over residue minus pi I limit z tends to infinity z f of z z f of z. So again, according to Jordan lemma, this term is equal to 0. Therefore integral over c f of z dz is equal to pi I summation over residue if poles doesn't lie on y-axis. So problems based on this. First question, integral minus infinity to plus infinity 1 by x square plus a square dx. So integral c 1 by z square plus a square dz. So z is equal to plus or minus ia, but z is always plus ia. We are only taking y is always positive. We are taking y as positive. Positive part only y is we are taking. Therefore, residue to find, we have an equation, numerator divided by derivative of denominator as a trick. So here it is 1 by 2z, that is equal to 1 by 2ia. So integral c f of z dz is equal to 2 pi I to 1 by 2ia is equal to pi by a. Second question, integral minus infinity to plus infinity x divided by x square plus a square into x square plus b square dx. So solution of this is integral over c z divided by z square plus a square into z square plus b square. So z is equal to plus or minus ia and z is equal to plus or minus ib, but we are taking only positives of this. So z is equal to plus ia and plus ib is only valid. Therefore residue at z is equal to ia is equal to limit z tends to ia z minus ia into z divided by z minus ia into z plus ia z square plus b square. So we got ia divided by 2ia into b square minus a square, that is equal to 1 by 2 into b square minus a square, and residue at z is equal to ib is equal to limit z tends to ib divided by 2ib into a square minus b square, that is equal to 1 by 2 into a square minus b square. So integral c f of z dz is equal to 2 pi I into 1 by 2 b square minus a square minus 1 by 2 a square minus b square is equal to 0. Then third question, integral minus infinity to plus infinity x square divided by x square plus a square into x square plus b square dx. Solution of this is integral c z square divided by z square plus a square into z square plus b square dz. So we are taking the valid points z is equal to plus ia and plus ib. So residue at z is equal to plus ia is equal to limit z tends to ia z square divided by z plus ia into z square plus b square is equal to minus a square divided by 2ia into b square minus a square. So that is equal to minus a divided by 2I into b square minus a square. This is one. Then residue at z is equal to ib is equal to limit z tends to ib z square divided by z square plus a square into z plus ib that is equal to minus b square divided by 2ib into a square minus b square that is equal to minus b divided by 2I into a square minus b square. So integral c f of z dz is equal to 2 pi I minus a by 2I into b square minus a square plus b divided by a square minus b square is equal to pi divided by b divided by a square minus b square minus a divided by a square minus b square is equal to pi divided by a plus b. Next question, fourth question, integral minus infinity to plus infinity x square divided by x raised to 4 plus 1 dx. So solution, integral c f of z dz is equal to integral z square divided by z raised to 4 plus 1 dz. So z raised to 4 is equal to minus 1 is equal to a raised to I pi n, where n is equal to 1, 3, 5, 7. We are taking n as odd values because in 1, 3, 5, 7 negative values of e raised to I pi n getting. So z raised to 4 we are getting. So we are taking the odd values. Then z is equal to e raised to I pi by 4, e raised to I 3 pi by 4, e raised to I 5 pi by 4, e raised to I 7 pi by 4. This up to here, these values are less than 1, so possible. Here these values are greater than 1, so not possible. Therefore, we need to check only 2 values of residue. So residue at e raised to I pi by 4 is equal to limit z tends to e raised to I pi by 4 which is equal to z square, not equal to z square divided by 4z cube. Then if you are multiplying with z on numerator and denominator, we got z into z square divided by 4 into z raised to 4 is equal to limit z tends to e raised to I pi by 4 z cube divided by 4 z raised to 4 is equal to z cube divided by 4 into minus 1 z cube divided by minus 4. So this is equal to e raised to I 3 pi by 4 divided by minus 4 is minus 1 by 4 into cos 3 pi by 4 plus I sin 3 pi by 4 is equal to minus 1 by 4 into minus 1 by root 2 plus I by root 2. Then in the next case, residue at e raised to I 3 pi by 4 which is equal to z square divided by 4z cube into z divided by z, that is equal to z cube divided by 4z raised to 4. So residue at e raised to I 3 pi by 4. So we got this as minus 1 by 4 e raised to 9 I pi by 4. So that is equal to minus 1 by 4 cos 9 pi by 4 plus I sin 9 pi by 4. So that is equal to minus 1 by 4 1 by root 2 plus I by root 2. We got integral C f of z dz is equal to minus 1 by 4 minus 1 by root 2 plus I by root 2 plus minus 1 by 4 1 by root 2 plus I by root 2, that is equal to pi by root 2. So next type is if function given is sin x or cos x. First question, integral minus infinity to plus infinity f of x dx. If a function contains sin x or cos x, we have to write sin mx or cos mx, that is equal to e raised to I mx. For example, a integral minus infinity to plus infinity sin mx divided by x square plus a square dx is integral c e raised to I mz divided by z square plus a square dz, that is equal to e raised to I mz divided by 2z at z is equal to ia. So we got e raised to minus ma divided by 2ai. So we got, therefore integral c e raised to I mz divided by z square plus a square is equal to 2 pi I e raised to minus ma divided by 2ia, that is equal to pi by a e raised to minus ma. Similarly, integral minus infinity to plus infinity cos mx divided by x square plus a square is equal to pi by a e raised to minus mx. And integral minus infinity to plus infinity sin mx divided by x square plus a square. Answer totally we are getting 0 because here there is no imaginary part for the answer. Only if the answer contains imaginary part, that part will be attributing to the sign component, and the real part answer is going for the cos component. Likewise we can do the questions. Now next question, integral minus infinity to plus infinity cos mx divided by x square plus a square into x square plus b square dx, that is integral c e raised to I mz divided by z square plus a square into z square plus b square. So here z is equal to plus ia and z is equal to plus ib. So if you are taking limit z tends to ia, e raised to imz divided by z plus ia into z square plus b square, that is equal to e raised to minus ma divided by 2ia into e square minus a square. So limit z tends to ib, e raised to imb divided by 2ib into a square minus b square, that is integral c e raised to imz divided by z square plus a square into z square plus b square is equal to 2 pi I divided by 2i into e raised to minus ma divided by a into b square minus a square plus a raised to minus mb divided by b into a square minus b square. So answer for minus infinity to plus infinity, cos mx divided by x square plus a square dx is equal to pi into e raised to minus ma divided by a into b square minus a square plus e raised to minus mb divided by b into a square minus b square, and integral minus infinity to plus infinity sin mx divided by x square plus a square dx is equal to 0. So some formulas we are going to discuss. Formulae: a integral 0 to 2 pi 1 by a plus b sin theta d theta is equal to 2 pi divided by root of a square minus b square. Integral 0 to 2 pi 1 by a plus b cos theta d theta is equal to 2 pi divided by root of a square minus b square. See, integral 0 to 2 pi 1 by a plus b sin theta whole square d theta is equal to integral 0 to b 1 by a plus b 0 to 2 pi 0 to 2 pi 1 by a plus b cos theta whole square d theta. So for both these questions, answer is 2 pi a divided by a square minus b square whole raised to 3 by 2. And next formula, integral 0 to 2 pi sin square theta divided by a plus b cos theta d theta is equal to 2 pi divided by b square into a minus root of a square minus b square. Next formula, integral 0 to 2 pi cos n theta divided by 1 minus 2a cos theta plus a square d theta, that is equal to 2 pi a raised to n divided by 1 minus a square. Then integral 0 to 2 pi sin n theta divided by 1 minus 2a cos theta plus a square d theta is equal to 0. Then integral 0 to 2 pi e raised to cos theta cos of sin theta minus n theta d theta is equal to 2 pi divided by n factorial. Then integral 0 to 2 pi e raised to cos theta sin of sin theta minus n theta d theta is equal to 0. So these are some useful formulas where direct answers are given. So this is actually a shortcut. With this complex integration and whole this complex analysis section has been completed. I will take the next section on next video. Till then, bye. Thank you.